Let's balance the oxidation-reduction reaction where iron 3 becomes iron 2 and at the same time bromide becomes hypobromite in basic solution. Hopefully at some point you'll be able to look at this reaction and see just by looking at it there's two half reactions. One is oxidation and the other is reduction. You should be at this point able to tell just by looking at it which one's being oxidized, iron 3, and which one is that being oxidized or is that being reduced, and is bromide being oxidized or reduced. We're going to do this in basic solution, and we're going to use the atoms, oxygen, hydrogen, electrons method. So first we'll start with iron. This is going to be half of the reaction. We're going to break it up into two reactions. We'll look at iron first. So as you can see, we've got iron 3 going to iron 2. The atoms are balanced. There's no oxygen or hydrogen, so we don't need to be concerned with that. But what we do need to see is that this is plus 3 on the left and plus 2 on the right. So the only way we can balance the charge, and we must balance it, is by adding one electron or more. We don't need to make it neutral, but we do need to make it the same net charge on each side. So which side gets an electron? The left side or the right side? If I add an electron over here, that's going to be a negative, so 2 plus positives and 1 negative is going to leave me with 1 positive on the right and 3 positives on the left. So that can't be correct. I'm going to add 1 electron to the left. Now you'll see that we've got 2 positives on the left side and 2 positives on the right side. So we're balanced. This would be oxidation or reduction. Which one is it? Well, you can see we're adding an electron to iron, and iron 3, and its charge is going down to iron 2. So iron 3 is being reduced. Anytime the electrons are on the left, it's reduction. So this is going to be the reduction half reaction. All right, so now let's do the other reaction. We're going to do bromide goes to hypobromite. So here we have BRO or Br minus and BRO minus. Okay, so our problem here is we've got the same number of atoms of bromine, so our atoms are balanced, but oxygen is not. The only way we can balance out oxygen is by adding water molecules, and I'm going to add 1. Now my oxygens are balanced on each side. But we've added hydrogen to the left, so we're going to need to add hydrogen to the right. I'm just going to write it on the next line and do it in steps. So I have 2 hydrogen atoms. I'm going to need to add 2 hydrogen ions to the right. The problem is this is a basic solution. So I need to add hydroxide. The way we do that is we add the same number of hydroxides to both sides that we added hydrogen to just one of the sides. So I'm going to add 2 hydroxides to the right and 2 hydroxides to the left. All right, so let's clean up this reaction a little bit. I've got here 2OH plus bromide plus water produces hypobromite. And I'm going to combine these into 2 water molecules because those would react to neutralize each other. And now you can see that I've got water molecules on each side, and so I can algebraically eliminate one on the left and one on the right. So the next step then is to balance out this equation with respect to charge. On the left side I have 3 minuses, and on the right I have only 1 minus. So I need to add 2 electrons to the right side in order to balance out the charge. So I'm going to just go ahead and copy everything down. I don't have water here anymore on the left. I only have 1 water molecule on the right, and I'm going to add, again, I have 2 negatives plus 1 is 3 negatives on the left. I'm going to add 2 electrons on the right. So now my charges, I've got -3 on the right and -3 on the left. So this equation now is, you can see the electrons where they were on the left side in the first reaction, they're on the right side in the second reaction. So this reaction, this is going to be my oxidation half-reaction. I know that because my electrons are on the right, and you can see that they've been lost. When they're on the right side, they've been separated from the species on the left, and so they're considered lost, and that's oxidation. So now what I want to do is add together my last 2 equations, my oxidation equation and my reduction equation. The problem is, if you look at this equation up here, I need to cancel out my electrons on each side, just so there's no electrons in the equation at all. And I only have 1 electron in this reaction with iron. So I need to multiply that reaction by something so I have the same number of electrons on the left as I do on the right and can cancel it out. So you can probably see that we just need to multiply everything in this equation by 2. That'll give me 2 electrons to cancel with the 2 electrons in the oxidation half-reaction. I don't need to multiply the oxidation half-reaction by anything. Okay, so that gives me, let's do it in blue, 2 iron 3 plus 2 electrons, so I'm multiplying everything by 2, produces 2 iron 2 plus. So you'll notice we've got a +6 minus 2 is +4, and over here on the right we've got +4, so it's still balanced. Okay, then I'm going to bring down this reaction. That's 2 hydroxide plus bromide. Let's make sure we're copying everything down correctly. Gives us hypobromite plus water plus 2 electrons. Okay, so did we do that correctly? Yes. All right, so now we're going to add these 2 equations together, and we'll get our balanced oxidation reduction equation. My electrons cancel out, and I'm just going to copy everything down. Doesn't matter the order. And then we're going to do a check to make sure everything is balanced out and make sure we've got everything the way it's supposed to be. Okay, so let's look at iron first. I've got 2 irons on the left and 2 on the right. Then let's do bromine. I've got 1 bromine here and 1 here, so that's balanced. Let's check oxygen. I've got 2 oxygens on the left. I've got 2 oxygens on the right. Very good. Let's check hydrogen. I've got 2 hydrogens on the left, I've got 2 on the right, and we're basic. We have basic solution because I've got hydroxide, there's no hydrogen ions. So we're balanced with respect to all the atoms. Let's check the charges. Okay, I've got 2 minuses, I've got 6 pluses, and I've got another minus. So what's my net charge on the left? And then we want to check our net charge on the right. I've got 2 pluses, 2 times 2 pluses, that's 4 pluses. And I've got 1 minus. So the net charge on the left side is 3 plus, and the net charge on the right side is 3 plus. So we're balanced with respect to our charges. That means we've checked everything, we're completely balanced, and this then is our answer for our balanced oxidation reduction reaction.